discuss a bit more today and then we will start writing and quickly get the lesson over with. So, I told you momentum kiyala kiyanne, let's say somebody is throwing a certain object at you, right? Then how easy or how difficult would it be for you to catch it? That is momentum. Let's say ඔයාගේ පැත්තට object එක විසිකද්දී ඔයාට කල්ලන්න අමාරුයි කියලා. Then that means momentum is high. If it's easy for you to catch, that means momentum is low. So it's kind of a measure of how easy or difficult is it for you to catch some object that is thrown towards you. That is one way of understanding momentum. Another way is, let's say an object is thrown at you or at some object. And at some, let's say, බිත්තියකට හරි මොකට හරි ඔයාගේ ඇඟට හරි වීසි කරා කියන ඔබ්ජෙක්ට් එකක්. වීසි කරාම let's say catch කරන එක නෙවෙයි ඒ ඔබ්ජෙක්ට් එකෙන් ඔයාට තියෙන impact එක. හිතන්න rigiform වලින් හදපු rigiform object, a ball or something is thrown towards you. So the impact that you will experience is very low because it's rigiform. Let's say එකම mass එක උනත් එකක් rigiform bottle එකම mass එක rigiform and iron balls දැන් තියෙන විදියක් නෑනේ. Let's say එකම velocity එකේ. So rigiform නැතු අපි කියමු lee කියලා. lee වලින් හද wood. A wooden object is thrown towards you at a certain velocity. The impact is comparatively low if, let's say, another object made of iron is thrown at you with the same velocity. Right? අරකේ impact එක වැඩි. So ඒ වගේ අපිට impact එක විදියට එක ගන්නත් පුළුවන්. නැත්නම් අපිට කොච්චර ලේසියෙන්ද අමාරුවෙන්ද අල්ලන්න පුළුවන් කියලා එහෙම ගන්නත් පුළුවන්. So I told you අපි නිකන් discuss කරා last week. Let's say there is a certain object of mass let's say 3 kilograms thrown towards you. Okay, then there's another object of mass 12 kilograms thrown towards you. 12 now we'll get 8 kilograms thrown at you, right? This is being thrown at a velocity of 12 ms minus 1. This is also thrown at a velocity of 12 ms minus 1, right? So there are two objects of different masses. They are both thrown towards you at the same velocity. Which one will it be more difficult to catch?
8 kilo.
Yes, 8 kilogram object will be more difficult to catch. මොකද දෙන්නම එන්නේ එකම ස්පීඩ් එකේ. velocity එක එකයි. අල්ල සාමාන්‍යයෙන් අල්ල එකම velocity නැත්නම් එකම ස්පීඩ් එකෙන් එන දෙන්නේ අපිට catch කරන්න වෙද්දී if it's heavy, it's difficult to catch. Right? So because of that we say මෙයාගේ one second. So here this has a mass is higher, here the mass is lower, but both of them have the same velocity. Both have the same velocity, right? Both have the same velocity. මෙයාගේ mass එක lower, මෙයාගේ mass එක higher. And because of that, මෙයාගේ momentum is lower, මෙයාගේ momentum is higher, right? Something that we discussed last week. So then let's look at another instance where again we have two objects. Listen carefully. We have two objects. This has a mass of 7 kilograms and there is another object of mass 7 kilograms, right? This is thrown at you at a velocity of 5 ms minus 1. This is thrown at you at a velocity of 8 ms minus 1. 11 ms minus 1. Which one will it be more difficult for you to catch? Alamai, which one will be more difficult to catch if both are thrown at you?
The second one.
Yes, the second one, 11 ms minus 1. Because they are both the same mass. Yes, correct. They are both the same mass. දෙන්නගේම mass එක එකයි නම් හයියෙන් එවන කෙනාව නේද අල්ලගන්න අමාරු. හිමින් එවනවා නම් it's generally like comparatively easier to catch. But if it's sent at you with a higher speed or with a greater speed, it is a bit more difficult for you to catch, right? So in this particular case, both have the same mass, but this has a velocity is lower, මෙයාගේ velocity is higher. Because velocity is higher, මෙයාගේ අපි කියනවා momentum වැඩි. ඇයි catch කරන්න අමාරුයි. So momentum is higher and මෙයාගේ momentum is lower. Now from this what we can understand is, in the first example, they both had the same velocity but mass එක හින්දා momentum වෙනස් වෙලා. Right? Therefore, mass is very important for momentum. In the second example, they both have the same mass but the velocities are different. Velocity වෙනස් වෙච්ච හින්දා momentum වෙනස් වුණා. So velocity is also an important factor for momentum. එහෙනම් ළමයි අපි කියනවා momentum calculate කරන්නේ මෙහෙමයි. Momentum is calculated like this. Momentum equals mass multiplied by velocity. In symbols, we can write this as momentum අපි ලියන්නේ simple p. Mass is simple m, velocity is simple v. So this is how we write that formula. So in this example, in this formula, or P were capital P දැම්මොත් your formula is wrong because capital P is pressure, right? In the future, in your second book, we will be learning about pressure, but that is a completely different quantity, right? Momentum කියන එක, pressure කියන එක. So capital P දැම්මොත් it's wrong. So you have to make sure that you use simple P. හොඳට simple P පේන්න ලියන්න ඕනේ. Okay, so mass වල SI unit එක kilograms, velocity වල SI unit එක ms minus 1. එහෙනම් momentum වල SI unit එක kg ms minus 1. Is it clear ළමයි? Tenuli, is it clear?
Yes.
Kedinuki?
Yes, teacher.
Ashwita? Hello? Ashwita, can you hear me?
Yes, teacher.
Is it clear?
Yes, teacher.
Okay, Chenuli?
Yes, teacher.
Okay. So I'm just calling out some random names. That doesn't mean ඒගොල්ලන් විතරයි හුවේ කියලා. Others also, if you have any questions, ask. Please do ask. Okay. Momentum කියලා topic එක දාගන්න ළමයි. Momentum. Put a star and write. Topic momentum. Put a star and write momentum. I hope you're writing. මාත් එක්කම ලියන්න.
Teacher, can you say from where we have to write?
From this topic momentum.
Okay, teacher, because I left and came.
Right, okay. Momentum ಇಂದ. Okay, quickly write this, Lamai. මම මෙහෙම එක තැනක board එක stop කරලා තිබ්බට I think you can also move the board around, no? So ඔයගොල්ලන් board එක move කරලා complete the note, huh? I'll give you 2 more minutes. Okay, Lamai, that's enough time. So here, who needs more time to write? Amma done? Or still writing? Yes, Amma?
Wait a minute.
Okay. Seneth? Onara? Okay. Okay, I'll give 1 more minute and then we'll do a few questions.
Done.
Okay. Now we will do a few questions. So before mama examples monad then karanne during the class straight away questions welta me amu because these are very easy. Just like F equals ma, just like any other equations, you know a lot of maths. It's just about simplifying, right? The only things that you have to be careful about are the units, right? Mass grams වලින් තිබ්බොත් make sure you convert to kilograms. Kilograms වලින් තිබ්බොත් ඒ විදිහටම දානවා no problem. Velocity නම් හැම වෙලේම වගේ උගන්ට එන්නේ ms minus 1 වලින්. So එතන momentum final answer කලියද්දී හැම වෙලේම kilograms kg ms minus 1 unit එක දාන්න ඕනේ. So සමහරවිට kg ms minus 2 දානවා වෙන වෙන units දානවා then it's wrong. Momentum nang the unit has to be kg ms minus 1. So simplification nang I don't have to teach you, it's about division, multiplication and all of that, right? So simplification careless mistakes karan depa and then units gana careful vela. Let's try a few questions from exercise 4.2. That is not that difficult. First 2 questions karan ban. First 2 questions I'll give 5 minutes. So I'll put a timer on the board because it's just about simplification. In case you need more time, we can definitely add more time, right? But for the moment 5 minutes වලින් කරන් try කරන්න බෑ. මම මේක board එකට දාන්නම්. The first two questions only. आप ये discuss कर ली तो टिक करो.
Miss, only the first two, right?
Only the first two, yes.
Isha done.
Okay. Okay, since there's a bit more time, I will give you all. There's 1.5 minutes more.
So when we are doing like always the mass should be in kilograms, right?
Yes, it's the SI unit of mass. Okay, Lamai, let's discuss. So the reason why I'm setting a timer is just to align you guys with time management, because that is a crucial factor when you're answering questions, right? for your term test, maybe for your O-level exam in another 1.5 to 2 years. So then my first again the mama 5 minutes, but this doesn't take 5 minutes. Might take 5 minutes. Okay, anyways, doesn't matter. The mass of a motor car is 800 kilograms. Find its momentum when it is moving at a velocity of 5 ms minus 1. So our formula P equals mv, simple P, yeah? Mass 800 kilograms. Velocity 5 ms minus 1. Oops. So momentum is 4000. Yes, correct, Onara. 4000 kg ms minus 1.
Tisha, we have to like correct it.
I think,
Like using a red pen, we have to correct it,
yes,
or like
yeah. Whenever we do questions, if you have to do like if they're like if you're correcting it during the class, use red. Okay, so P equals mv again. Mass of an object is 600 grams now, Lama, yeah? 600 grams now, you have to convert it to kilograms. Or මෙතනම 1000 වලින් divide කරන්න පුළුවන්. නැත්නම් වෙන තැනක divide කරලා 0.6 කියලා ගන්න පුළුවන්. Velocity is 5 ms minus 1. අන්න units වැරදිලා. 600 grams, so you have to convert it to kilograms. So that means you have to divide by 1000. So 0.6 multiplied by 5 is 3 kg ms minus 1. Make avada lamai. Did you all understand the second one? Chenuli, did you get the second one?
Tisha, I got 5 kilograms ms minus 1. Second one.
Can't be, no, because now 600 grams or kilograms karada you divide by 1000. Then you get 0.6 kilograms. So momentum kyanne mass, which is 0.6 kilograms multiplied by velocity 5 ms minus 1. So 6 times 5 is 30. Or එක decimal place එකක් තියෙනවා. So it's 3. The answer is 3.
Okay, Tisha.
Okay. Chenul, did you get this answer?
Yes, teacher.
Ama?
Yes.
Okay. Then now we will move on to third, fourth and fifth questions. Now again, second decay unit mistake එක වුණා නම්, now take this chance to make sure that it doesn't happen again, right? මං කිව්වා units හොඳටම බලන්න. Grams the kilograms the velocity වල unit කොහමද? Velocity නම් most of the time 99% of the time you get in ms minus 1. Okay, quickly start. And then after miscellaneous okay, I want you to do only a few questions. And then we can move on to friction. Quickly do. Let me know if you have any questions. I will set a timer for 8 minutes. While you do it, give me 2 minutes, Lamai.
Teacher, done.
Okay, who else is done, Lamai? Tenuli, try joining again. Then you might be able to see the whiteboard. Lamai, what about others? Seneth, still doing or done? Dinuki?
Done.
Seneth? Amma?
Done, teacher.
Okay, Chenuli and Onara?
Done, teacher.
Okay. Chenuli, can you... Mm, why can't you see the whiteboard? So මේ පැත්තෙන් නම් මං share කරලා තියෙන්නේ, like I have හැමෝටම දීලා තියෙන්නේ access එක board එකට. By any chance are you having a connection issue, Tenuli? චුට්ටක් බලනකොට තියෙන්නේ sometimes this happens සමහරවිට ටිකක් ඇවිල්ලා චුට්ටක් කරලා හිටියට පස්සේ තමයි board එක පේන්න පටන් ගන්නෙ. It's probably because of the internet connection, right? Or else සමහරවිට I rejoin with it පේන්න පටන් ගන්නවා. Since it didn't happen to you, just let's wait for a bit and see. Anyhow, I will send you the recording, just remind me, okay? For the parts that you're missing. Okay, Lamai. So third question, a certain object has a mass of 200 grams. If it moves with a velocity of 4 ms minus 1, what is the momentum? Momentum equals mv. Okay. Chenuli, what is the answer to this?
So over 5 kilogram ms minus 1.
4 over 5 kilograms. 4 over 5 kilogram ms minus 1. Okay, we'll see. So mass is 200 grams. We know if it's grams, we have to convert it to kilograms. That means we have to divide by 1000. Multiplied by velocity is 4 ms minus 1. So, second, 0.2 kilograms multiplied by 4 ms minus 1, that would be 0.8.
Kilogram. MS minus 1.
Yes. So 4 over 5 කියන එකත් හරි. But ඒක simplify කරන්න පුළුවන් 0.8 වලට. Okay. Then let's look at the fourth one. Ashwita, what did you get?
I got 12 ms minus 1.
Okay, we'll see. P equals mv. This time they have given the momentum as 6 kg ms minus 1. Mass like 500 grams, we have to convert it to kilograms, then it would be 0.5 kilograms. And velocity, we do not know, that is what we have to find. So my velocity එක පැත්තක තනි කරොත්, that means 0.5, I have to bring it to the other side, then it becomes division, right? 6 divided by 0.5. Usually denominator we don't keep a decimal value, so in order to remove the decimal, I am gonna multiply this by 10. So this also I multiply by 10. So what I have is 60 divided by 5, which is 12 ms minus 1. Okay. Then fifth one, an object of mass 3 kilograms is projected upwards. At the beginning of the motion, its velocity is 10 ms minus 1.
30 kilograms ms minus 1.
Okay. Amma, what did you get?
30 kg ms minus 1 teacher.
Okay, 30. So both of you got 30. We'll see fifth one. A. Object of mass 3 kilograms, velocity at the beginning. Now this is projected upwards, no? So if some object is projected vertically upwards, at the beginning there has to be a motion, has to be a velocity. So here the velocity is 10. So momentum is mass times velocity. Mass in this particular case is, Seneth, I need your answer for B part. 3 kg, velocity is 10 ms minus 1. That is correct, 30 kg ms minus 1. In the B part, what would be the momentum when it reaches the highest point? Now we know when we project an object vertically upwards, at the beginning there has to be a velocity, otherwise it will fall down. No? So at some point, here will come a point where it's at the very top of the motion. Seneth, what did you get for B? Very good, correct.
Teacher, 3 kilograms ms minus 1.
No. The reason is when the object is projected upwards, what would be the momentum when it reaches the highest point, right? මෙයා කොතන හරි ගිහිලා නවතින්නේ එයාගේ velocity 0 ms minus 1 වෙන තැනනේ. Do you get it?
0 kg ms minus 1.
Yes, correct. එන්නේ ඒකයි අපි එතන 0 කියලා ගන්නෙ because when the object is projected vertically upwards, at the beginning there has to be a velocity, otherwise it will not go up. But when it reaches the highest point, එයා තවත් උඩ යන්නේ නැහැ කියන්නේ its velocity has become 0. So, mass 3 kilograms correct. අපි හදලා පෙන්නන්න ඕනේ. ඇයි 0 උනේ? Because velocity is 0. එහෙනම් momentum is 0 kg ms minus 1. Alright, good. With that we have come to the end of the lesson. Mass and weight අපි කලින් කරා F equals ma කරද්දිම. Miscellaneous එකේ there are a few questions that I want you to try during the class. Itu ටික homework. Fourth, this is page 96, huh? Page 96 එකේ fourth එක. I will put on the board as well. කරන් පටන් ගන්න ළමයි. Then 9th and 10th. Then we'll move on to friction. Momentum ටික නම් අපි already කරානේ momentum question, so it's all right. Okay, quickly do this. I will give you 10 minutes. Abi 8 minutes wage තියමු. If you need more time, I will give you more time. And even if you finish before the timer, just let me know in the chat box. Huh? Meanwhile, Thenuli, can you see the whiteboard now? Still no? Let me check. Check now, Thenuli. Still no. Still no. Oh, I'm at rejoin උතුනානේ නේද? What's going on? You rejoin no තෙනුලි. ඔයා ගිහිල්ලා එකපාරක් ආවනේ. අනිත් කාට හරි issue එක තියනවද and or like can everybody else see the whiteboard? Does anyone else have the same issue?
No, teacher.
Okay. I'll check. I'll check තෙනුලි. Wait. Tenuli, were you able to see the whiteboard earlier? ඉස්සල පෙනුනද මුලින්ම ක්ලාස් එකට join වෙන වෙලේ? Ah yes. Okay. Chenuli අපි ඔයා පුළුවන් ටික කරන්න Chenuli. Once you complete and others also complete, we will discuss. If you're done or if you have any questions, let me know. Who needs more time, Lamai? If you want, I can give you more time. Chenuli, she was absent last week. What about Ashwita? Done?
Okay, teacher. Okay, teacher.
Seneth?
Yes.
Dinuki? Dinuki, Onara? Onara
Teacher
done?
done.
Okay, Onara? Alright, Dinuki. Anyways, we'll discuss. Okay, we'll discuss the fourth one. The mass of a certain object is 6 kilograms. What is the force that could have acted on it if its velocity increased from 5 ms minus 1 to 13 ms minus 1? Let's ask from Ama.
9.6 Newton.
9.6
6 Newton.
newtons. Okay, we'll do the calculation here. So here what has happened is that now the object, the mass is already given. Okay, they are asking us the force, right? Velocity වැඩි වෙලාලු 5 ms minus 1 ඉඳන් 13 ms minus 1 වෙනකම්. If velocity has increased, we know it's clearly acceleration, right? So අපි ගාන හදමු මෙතන හදන්නම් මම. So if velocity has increased, we know it's definitely acceleration, right? එහෙනම් අපි acceleration හොයමු. We know acceleration is final velocity minus initial velocity divided by time. මම ඔයගොල්ලන්ට කියා දුන්නානේ මේක. Final velocity minus initial velocity divided by time. So final velocity is 13 ms minus 1, right? Final velocity is 13 ms minus 1, initial velocity is 5 ms minus 1, time is 5 seconds. 13 ms minus 1, 5 ms minus 1, time is 5 seconds. So 13 minus 5 is 8. 13 5, so 13 minus 5 is 8. Divided by 5 seconds, we have 1.6 ms minus 2. 1.6 ms minus 2 is the acceleration, right? Then we know we can use F equals ma. Mass they have already given as 6 kilograms. So mass is 6 kilograms. Kilograms වලින් තියනවා කියන්නේ unit එකත් හරි. Acceleration we found here, it's 1.6 ms minus 2. So we have to multiply 1.6 by 6. 6 times 6 is 36. 6 times 1 is 6 plus 3, 9. Correct. 9.6 newtons. 9.6 newtons. Okay. Ninth question. The mass of an object is 60 kilogram. What is its weight? Tenuli, what did you get for that? I don't know if Tenuli was able to do the question.
600 Newton.
Okay. Tenuli, did you get an answer? Okay, ninth one we'll discuss. The mass of an object is 60 kilograms. What is its weight? We know W equals mg. Mass is 60 kilograms. Gravitational acceleration, they have asked us to take 10 ms minus 2. So W or weight is 600 newtons, correct. If the gravitational acceleration on the moon is 1 over 6 that of the earth, what would be the weight of the above object on the moon? Dinuki, what did you get for that?
100 newtons.
Okay, you got 100 newtons. We'll see. So gravitational acceleration on the moon is 1 over 6th of that on earth, right? So then in a gravitational acceleration on the moon kiyanne, now on earth it's 10 ms minus 2. So on the moon it's 1 over 6th that of the earth. Now moon එකේ වෙන්නේ 1 over 6 multiplied by 10 ms minus 2. එතකොට W equals mg දැම්මා මේ moon එකේ. Mass is still 60 kilograms. Now the gravitational acceleration is this. 1.6 into 10 ms minus 2. So we can see that we have 10 here. Then 10 multiplied by 10, we have 100 newtons as the weight on the moon. Metana, it's alright to skip this step. මේ step එක කරේ නැති වුණාට කමක් නැහැ. Until up to which point did you hear? Ama, කොතනට වෙනකන් දැහුනේ?
fourth question එක හදලා ඉවර වෙනකන් teacher.
Fourth question එක හරි නේද?
ඒක හරි teacher.
Okay, so
ninth එකේ 1 එකයි 2 second one එකත් හරි.
ninth එකේ 1 and 2 හරිද?
හරි teacher.
එතන මොන ටිකද ඇහුන්නේ නැත්තේ?
මට teacher කියපුවා ඇහුන්නේ නැහැ.
Ah, really? What about others? මගේ connection issue එකද දන්නේ.
No teacher can hear.
සමහර මොකක් හරි ඒක තමයි. අනිත් අයට අහනවා නම් it must be a connection issue. If you miss something again and board එකේ තියෙන එක තේරෙන්නේ නැත්නම් මට පොඩ්ඩක් කියන්න.
Okay teacher.
Okay. Because සමහර ලාවට මේ time එකේ මටත් connection issues එනවා. Okay, anyways, last question. Weight of an object is 5 newtons. At a certain instance, its momentum is 6 kg ms minus 1. Due to a force applied in the direction opposite to the direction of the motion, the velocity of the object is decreased to 4 ms minus 1 during 4 seconds. What is the force exerted on the object? Okay, we'll see. Can you tell me your answers if you all did this? What are the answers you all got? Kartik Yanman, aap answers?
0.9, 0.5 newtons.
0.5 newtons.
Yes.
0.5 Newton.
0.5 newtons. I didn't hear Ama's answer.
1 newton teacher.
1 newton, okay. Seneth? Shenuli wasn't there last week, no? What about Seneth? Tenuli, Onara? Okay, we'll start discussing weight of an object is 5 newtons. Hari. Then dila තියෙන ටික අපි චුට්ටක් ලියාගමු. Weight is 5 newtons. Okay. Momentum is 6 kg ms minus 1. This is supposed to be a P momentum. So this object, it's moving no. හැබැයි දැන් යාට අනිත් පැත්තට force එකක් දාපු හින්දා යාගේ velocity එක අඩු වෙනවලු 4 ms minus 1 වලට within 4 seconds, right? Okay, we'll see. Now we know W equals mg, right? So weight එක ඒගොල්ලන් දීලා තියෙනවා 5 newtons කියලා. mass එක අපි දන්නේ නැහැ. Gravitational acceleration 10 ms minus 2. So mass එක කියලා කියන්නේ 5 newtons divided by 10. මේ 10 එක මේ පැත්තෙන් ගෙනිච්චාම division වෙනවා. So mass is 0.5 kilograms. Then momentum අපිට දීලා තියෙනවනේ ළමයි. එහෙනම් momentum වල formula එක මොකක්ද? Momentum equals mass times velocity. Momentum is 6 kg ms minus 1. Mass is 0.5 kilograms. Making අපිට velocity එක හොයාගන්න පුළුවන්. So I will bring this to the other side, then it becomes division. So velocity is 6 divided by 5, which is 12 ms minus 1. ඒ කියන්නේ මේ object එක move වෙවි ඉඳලා තියෙන්නේ 12 ms minus 1 වලින්. But the velocity, due to a force applied in the direction opposite, velocity has decreased to 4 ms minus 1 during 4 seconds. Velocity 12 ඉඳන් 4 ms minus 1 වලට අඩු වෙලා within 4 seconds. ඒ කියන්නේ ළමයි මෙතෙන්දී අපිට acceleration calculate කරන්න පුළුවන්. අපෙන් අහන්නේ අන්තිමට මොකද්ද? force එක. So force එකට F equals ma ඕනේ. mass එක we already have, but acceleration we don't. So what I'm going to do is I am going to calculate acceleration. Acceleration equals ළමයි deceleration කියලා ඔයගොල්ලන් calculation කරන්නේ නැහැ. හරිද? අපි හැම වෙලේම calculate කරන්නේ acceleration වලට. acceleration minus වුණොත් අපි minus එක හරලා deceleration ලියනවා. but calculation එකේදී ගාන හදද්දී අපි deceleration කියලා ලියන්නේ නැහැ. අපි calculate කරන්නේ acceleration. if it becomes negative only we write it as deceleration. ඒක මතක තියාගන්න. because it's a mistake that some
Teacher,
do. Yes.
I can't hear you. It was like,
Can you hear me now?
now only I can hear. Before part you explaining, no, I can't hear.
Okay, so what I mentioned was that now here the velocity is decreasing. So velocity is changing within a certain time period. So we are going to calculate acceleration. So මෙතන definitely වෙලා තියෙන deceleration එකක් නේ. හැබැයි අපි calculation එකේ deceleration කියලා නෙවෙයි calculate කරන්නේ. අපි calculate කරන්නේ acceleration. Acceleration minus වුණොත් අපි ඒක deceleration කියලා ලියනවා. That's a different story. But we don't calculate deceleration, right? So final velocity is 4 ms minus 1. Initial velocity is 12 ms minus 1. Time is 4 seconds. So 4 minus 12 means minus 8 divided by 4. We get the acceleration as minus 2 ms minus 2. Then අපේ force එක නේ යන්නේ. අපිට force එක ලියන්න පුළුවන් F equals ma දාලා. Mass of the object we found it here is 0.5 kilograms. දැන් ළමයි මෙතන අපි deceleration හොයන්න ඕනේ නැහැ. මොකද F equals ma වලටත් ඕනේ acceleration ම තමයි. So අපි acceleration එහෙමම ලියනවා minus 2 ms minus 2. So 0.5 multiplied by 2 means minus 1 newtons. කොහොමද මේකට minus 1 එකක් ආවේ? So force is a vector ළමයි. Right? Force is a vector. ඕන වෙලාවක minus එකක් එනවා කියන්නේ එයාගේ direction එක වෙනස් වෙලා. So minus 1 newton force එකක් ඇවිල්ලා මේ කියන්නේ මෙයාගේ force එක 1 newtons in the opposite direction. Minus 1 කියලා ආවේ ඒකයි. The sign minus means the direction. ඇත්තනේ opposite direction එක කියලා තියෙනවානේ. Due to a force applied in the direction opposite. ඒක හරි. අපේ ආපු උත්තරේ හරි. So it's 1 newton, minus 1 newtons ආවා. So we write it as 1 newtons in the opposite direction. Did all of you understand this question? Chenuli, Ashwita, Seneth?
Yes, teacher.
Yes, teacher.
Seneth? Then Dinuki, Tenuli, Onara, Ama.
Yes, teacher.
Yes, teacher.
Tenuli? Okay. So now we will move on to friction. We are finally done with Newton's laws of motion. Friction api adi ඉවර කරනවා. Okay, put the topic friction. Okay. Let's say there is a table top. මොකරි මේසයක් මෙහෙම තියෙනවා table එකක්. Table එකේ top එක, right? Then on this table I have kept an object like this. Okay. So this object is just staying like that, right? Now what I'm going to do is මට මේ object එක I want to move it towards, let's say මගේ right එකට, right? So I want to move this object a little further. So ඒක move කරන්න ඕනේ හින්දා මම දෙනවා මෙන්න මෙහෙම යාට force එකක්. Let's say මුලින්ම චූටි force එකක් දුන්නා කියලා. පොඩි force එකක් දුන්නා 2 Newton force එක. දැන් ළමයි මෙන්න මෙහෙම දෙයක් තියෙනවා. Now this object, right, this object which is in the shape of a cube is in contact with the table surface, right? මෙයා මේ table surface එකත් එක්ක contact වෙලා තියෙන්නේ. එතකොට මොකද වෙන්නේ? When two surfaces are in contact with each other and one of the surface is trying to move, අනිත් surface එක කැමති නැහැ හැම motion එකක් කරනවට. So in this particular case, the box is kept on the table. The box and the table are in contact with each other. When the box is trying to start a motion, the table does not like that motion. Table එක කැමති නෑ motion එකක් කරනවට. එතකොට අපි කෙලින්ම box එක move කරේ නැතත් අපි box එක move කරන්න හදනවා නම් ඒ කියන්නේ දැන් හිතන්නකෝ I'm applying a 2 Newton force. 2 Newton force is not enough to move the box. Box එක move කරන්න 10 Newton force එකක් දෙන්න ඕනේ. හැබැයි මම චුට්ට තමයි වැඩි කරන්නේ. So initially I only give 2 Newton force. Now the box is in contact with the table, no? Table එකට තේරෙනවා මෙයාව දැන් move කරන්න තමයි හදන්නේ කියලා. Table එක දැන් කැමති නෑ මේ motion එකට. Table එක මොකද කරන්නේ? එයා මේ motion එකට opposite direction එකට මෙන්න මෙහෙම force එකක් දෙනවා. That force is called friction. That force is called friction, right? So whenever two surfaces are in contact, whenever, right? So let's say if I'm standing on the floor, my foot, both of my feet are in contact with the floor, right? So if I'm trying to move, the floor doesn't like the motion, so the floor will apply a friction to my feet, right? Then let's say there's a vase on this table. So if I'm trying to move the vase, මම චුට්ට force එක වැඩි කරනවා. දැන් table එකට තේරෙනවා මෙන්න මෙයාව move කරන්න හදන්න කියලා. Table එක අනිත් පැත්තට force එකක් දෙනවා. Trying to stop the motion. So likewise, whenever two surfaces are in contact with each other and one of the surfaces are moving or even trying to move, the other surface doesn't like it. So අනිත් surface එක මොකද කරන්නේ? Move වෙන පැත්තට නෙවෙයි opposite පැත්තට force එකක් දෙනවා. එයා හදන්නේ පුළුවන් තරම් මේ motion එක නවත්තන්න. That force only we call friction. Okay. So let's write a few sentences. මේක මම එක ලොකු scenario එකකින් cover කරනවා මුළු concept එකම because it's not that complicated. ඒකින්ද අපි මුලින්ම පොඩි sentence එකක් ලියමු. Don't draw this. let's say. So then let's put another stand. Let's write the proper definition of friction. This is also on the textbook. Don't worry about this sentence. I will read that. We'll talk about it a bit, but it's the same story. Let me be honest with you. May definition එක මටත් මතක තිබුණේ නැහැ. I copied it from the textbook and I wrote it, right? The reason is because sometimes studying doesn't mean that you are studying like a parrot, right? By hearting everything. So may යට තියෙන sentence එක textbook එකේ තියෙන definition එක, this means the same thing as the first sentence. So definitely the first sentence makes more sense to you. ඒකම තමයි second sentence එකේ පොඩ්ඩක් complicate කරලා ලියලා තියෙන්නේ. Then make and the ganda. After that I will talk about the second sentence a bit more. Quickly write and draw this and let me know when you're done.
Teacher done.
Okay, what about others?
Done, teacher.
Who needs more time? Okay, who needs more time? Onara done? Tenuli? Okay, all right. So now I'm gonna let's talk about this instance. From that instance, we are going to be covering all the types of frictional forces, right? Then right? So let's say we have a surface. This could be a floor, tabletop, or whatever. Now I have an object, right? So this is my object, right? This is my object. X කියලා අපි කියමුකෝ. X. Okay. So what happens is that now I want to move X a bit forward, right? So because I want to move X, what I'm going to do is I'm going to apply a force of 2 newtons to X, right? Now X is in contact with the table surface, right? X in a table surface එකත් එක්ක contact වෙලා. Now when I'm trying to, now the 2 Newton force is not enough to move X, but at least I'm trying to move X ne. Then X කියන object එක is in contact with the table surface. So the table surface feels that X is trying to move. Then what happens is that the table surface doesn't like it, so it will apply a friction in the opposite direction to stop that motion. So then මම apply කරේ 2 Newton force එකක් නේ. So then table එක කැමති නෑ මෙයා move වෙනවට. Table එක මොකද කරන්නේ? Opposite direction එකට දෙනවලු 2 Newton force එකක්. දැන් මොකද කරන්නේ? මම 2 Newton force එකක් දීලා මෙයාව move කරන්න හදනවා. හැබැයි table එක අනිත් පැත්තට 2 Newton force එකක් දෙනවා. දෙපැත්තට 2 Newton forces දෙක cancel වෙන හින්දා x කියන object එක move වෙන්නේ නැහැ. Right? So the object X will not move. Okay. Now the same object, මම එකම object එක තමයි පෙන්නන්නේ. Okay. So now again the same object X. දැන් මම ඉස්සලා 2 Newton force එකක් නේ දැම්මේ. දැන් මම force එක ටිකක් වැඩි කරලා I'm going to apply a 3 Newton force. මම දානවා 3 Newton force එකක්. දැන් අනිත් surface එක මොකද්ද? table එකනේ. table එකට තේරෙනවා දැන් ඔන්න මෙයා වැඩිපුර force එකක් දාලා move කරන්න හදන්නේ කියලා. Now the table doesn't like this motion no. table එක මොකද කරන්නේ? එයාත් අනිත් පැත්තට frictional force එක දෙනවා 3 Newton friction එක. So earlier I only applied 2 Newton force. The table applied a friction of 2 Newton force. The forces balance and the object X did not move. දැන් move වෙන්නේ නැති හින්දා මම පොඩ්ඩක් force එක වැඩි කරා. දැන් table එක මොකද කරන්නේ? එයාත් force එක වැඩි කරනවා. friction එක තවත් වැඩි කරනවා එයා. So මම 3 Newton force එකක් දුන්නාම the other surface will also give a 3 Newton force friction. Again the two forces will balance. May 3 Newton force එකයි friction 3 Newton force එකයි balance වෙලා X object will not move. Then now what I'm gonna do is I'm going to increase the force and I'm going to apply a 4 Newton force. දැන් මම 4 Newton force එකක් දාද්දි මොකද කරන්නේ? table එක එයා දන්නවා හරි මෙයා මෙන්න force එක වැඩි කරා දැන් මෙයා කොහොමරි motion එක පටන් ගන්න හදන්නේ කියලා table එකත් අතාරින්නේ නැහැ. එයා දෙනවා 4 Newton force එකක්. Now what happens? Again the 4 Newton force I applied and the 4 Newton force that the table surface the friction table surface gave, they are both again balancing. Again the object will not move. හරි. දැන් මම මොකද කරන්නේ? now what I'm going to do is that I'm going to increase my force more. Right? මම දැන් force එක වැඩි කරන්න හදන්නේ. Now ඉස්සර 4 newtons දැම්මේ. මම දැන් දානවා 5 newton force එකක්. I'm going to apply a 5 newton force. Now the problem is that මම මගේ force එක වැඩි කරා. දැන් table එකට තේරෙනවා මෙයා දැන් move වෙන්න පටන් ගන්න හදන්නේ. Table එක හදනවා කොහොමරියේ motion එක නවත්තන්න. එයා friction එක දීලා, but the problem is table එකට 4 newtons වලට වඩා වැඩියෙන් friction දෙන්න බෑ. 4 newtons is the maximum friction that the other surface or the table surface can give. Now I gave 5 newton force, but the table can only give 4 newton friction force. මේ පැත්තට 5යි මේ පැත්තට 4යි. So balance වෙලා එකක් ඉතුරු වෙලා this object will move forward with a 1 newton force. මේ 5න් 4ක් මේ friction එකට cancel වෙනවා. So it will move forward with a 1 newton force. Up to that point, is it clear? Chenuri? Chenuri, is
Yes, teacher.
Okay. Seneth, Dinuki,
Yes, teacher.
Ashwita and Onara?
Yes, teacher.
Onara? Tenuli Ama?
Yes, teacher.
Lasas? Okay, Seneth, okay. All right. Now we'll talk about the rest, right? We'll talk about the rest. So let me extend the table surface a bit more. Then මොකද වෙන්නේ? හරි. X object එක my object X. Then මම ඉස්සර දුන්නේ 5 newton force එකක්නේ. Then මම force එක වැඩි කරලා මෙයාට දෙනවා 6 newton force එකක්. But still the table can only give 4 newton force. එතකොට this object will start moving with a force of 2 newton balance එකක් වෙනවා. Because I give 6 newton force, friction is 4 newtons. එතකොට මගේ 6න් 4ක් balance වෙනවා friction එකට. So only 2 will be remaining. So the object will move forward with that 2. Right? Then likewise, I can increase my force more and more. එතකොට friction එක subtract වෙලා ඉතුරු ටිකෙන් මගේ object එක move වෙනවා. So let's say now I increase my force to 7 newtons, but still the table can only give 4 newtons. And now my object X will move with a total force of 3 newtons. Now this is the scenario. Right, මුලින්ම මොකද කරේ? Let me go through it one more time. Listen very carefully. මුලින්ම I have an object X which is kept on a table surface. This is all the same object at different stages, right? So I have kept it on a table surface and I gave us very small force, 2 newtons. Now the other surface, which is the table surface, feels that the object X is going to move. And the table does not like it. So what the table does is that it gives a resistive force in the opposite direction, trying to stop that motion. That resistive force is what we call friction. දැන් මෙතන මේ red වලින් තියෙන friction. So I gave a 2 newton force. The table gave a friction of 2 newtons in the opposite direction. මගේ 2 newtons අර 2 newtons cancel වෙන හින්දා this object will not move. Now what I do is I increase my force to 3 newtons. Then the table surface feels දැන් මෙයා move වෙන්න හදන්නේ. Table surface එක අතාරින්නේ නැහැ. එයාත් යාගේ friction එක වැඩි කරනවා 3 newtons වලට. මගේ 3 newtons with friction 3 newtons cancel වෙලා again the object will not move. Now what I do is I increase my force to 4 newtons. Table එක ආය අතාරින්නේ නැහැ. එයාට තේරෙනවා මෙයා කොහොමද move කරන්න හදන්නේ කියලා. එයාගේ friction එකත් එයා වැඩි කරනවා 4 newtons වලට. Again my 4 newtons and the friction 4 newtons balance and this object will still not move. Now what I do is I increase my force more to 5 newtons. Right? But The table surface can only give 4 newtons. එහෙනම් එයාට තව දාන්න ඕන වුණාට එයාට දාන්න පුළුවන් maximum capacity එක 4 newtons විතරයි. Now I give 5 newtons no. So මෙතන balance එක 1 newtons වලින් this object will start moving. Then I will increase my force more and more, but the table surface can only give 4 newtons as friction. So after this point the object will keep on moving, right? So here මෙන්න මේ point එක ළමයි. මෙන්න මේ point එක. That means the maximum friction that the other surface can give is 4 newtons no. This maximum friction that the other surface can give, this is called limiting frictional force, right? Limiting frictional force. So limiting frictional force is the maximum friction that the surface can exert, right? 4 newtons is 4 newtons is maximum friction. So this is the limiting frictional force. Before the limiting frictional force, when I'm applying forces again, then my limiting frictional force is 4 newtons ne. 4 newtons වලට කලින් මම 2 දැම්මා 3 දැම්මා, but the object did not move, right? So මේ හරියේ මෙන්න මේ ටිකේ I apply a force and the other surface is also applying a friction. මගේ force එකයි friction එකයි balance වෙලා the object does not move. The friction applied at the stages where the object does not move, these are called static frictional force. Static frictional force. මේ කියන්නේ the frictional force exerted by the surface when the object is not moving. When the object is not moving, right? So object is not moving. ඇයි මම දෙන force එකට balance වෙන විදිහට friction අනිත් පැත්තෙන් එන හින්දා. ඒතර ඒ වෙලේ apply වෙන frictions වලට කියන්නේ static friction කියලා. So here මෙයා static frictional force. මෙයා static frictional force. මෙතන මම දෙන force එකයි limiting මම දෙන force එකයි table එකෙන් දෙන force එකයි දෙකම equal. And that is the maximum friction that the other surface can exert. So this is the limiting frictional force. මම දෙන force එක limiting frictional force එකට equal කියන්නේ මෙතන තමයි the object is about to start the motion. Right? The limiting frictional force is the maximum friction that the other surface can give no. So එයා දෙන maximum friction එකටම දැන් මමත් match කරා. දැන් මෙතනින් පස්සේ මම එක decimal එකක් හරි වැඩි කරොත් මගේ object එක move වෙනවා. Why? Because 4 newtons වලට වඩා limiting frictional force එක වැඩි වෙන්නේ නැහැ. That is the maximum friction that the other surface can give. So limiting frictional force එකට equal force එකක් මම exert කරන තැනදී this is the point where the object is about to start the motion. පටන් ගත්තේ නැහැ but about to start. Then what about this part? මේ කොටසේදී the object is moving now, right? The object is moving, but is there friction? Object එක move වුණා කියලා නෑ, friction එකක් තියෙනවා. Friction is still there. Friction is still there. So the friction force exerted by the other surface, one second. So here the object is moving but still the frictional forces are there. So these are called dynamic frictional forces. So dynamic frictional force means the frictional force exerted by the surface when the object is moving. Object එක move වුණා කියලා නෑ, තාම friction තියෙනවා. Friction තිබ්බට object එක move වෙනවා because the force that I am exerting is greater than the limiting frictional force. Did all of you understand this situation? මේ මුළු scenario එකම තේරුණාද? Does anybody have any questions? Anybody ළමයි? Dinuki, is everything clear?
Yes, teacher.
Okay, Ashwita?
Yes, teacher.
Okay. එහෙනම් මේක අඳගන්න බලන්න ළමයි. So 1 2 3 4 5 6 boxes 6ක් නේ ඔයගලන්ට මේ normal විදිහට මදින්න පුළුවන් වෙන්නේ. So ගොඩක් ඉඩ තියන්න නැතුව අඳගන්න බලන්න මේක. Quickly draw. Let me know when you're done writing, lamai.
Teacher, done.
What about others? Let me know when you're done, lamai.
And teacher.
Okay. Lasas, Ama.
And teacher.
All right. Now that you wrote this, now we know what static friction is. We know what limiting frictional force means, and we know what dynamic frictional force means, right? Then lamai, let's say I draw a graph. X-axis එකේ තියෙන the force that we apply, right? The force that we apply in newtons. Y-axis එකේ තියෙන්නේ friction. Friction, that is also in newtons because friction is also a force, right? Now let's see what happens here. දැන් ළමයි මම බිඳුවේ ඉඳන් when I'm slowly increasing my force, the other surface is also increasing the frictional force. So මුල ටිකේ තියෙන graph එක මෙන්න මේ වගේ. The graph looks like this. So that means මම force එක එන්න වැඩි කරද්දී, the force that I apply, මං apply කරන force එක එන්න වැඩි කරද්දී අනිත් surface එක friction එකත් එන්න වැඩි කරනවා, right? friction will also be increasing, right? And then what happens is that there will come a point where the other surface can only apply a maximum frictional force. ඊට වඩා යට apply කරන්න බැරි තැනක් එනවා. Right? Let's say මෙන්න මෙතන තමයි ඒ තැන. Right? So here මම මේක මෙතන label කරන්නම් 4 newtons. According to this question, it's 4 newtons. According to this scenario, it's 4 newtons, right? එතකොට, when the force that I apply is 4 newtons, the force that the other surface gives, which is the frictional force, is also 4 newtons, right? මෙතනින් පස්සේ මොකද වෙන්නේ? කොහොම shape එකක් ගන්නේද? Will it be a shape like this, or will it be a shape like this? මෙහෙම shape එකක් වෙයිද? Or will it be a shape like this? කෙලින්ම මෙහෙම දිගටම වැඩි වෙනවද? Or will it be a shape like this? First, second or third? First, second or third? What do you think?
Third.
Okay, Dinuki says third. Others?
Second.
Ashita says second. Chenuli, what do you think? Seneth? Amma?
Third.
Okay, Chenuli says third. Amma, Onara, Lasas? Tenuli? Okay, first. Okay, ළමයි. අපි චුට්ටක් බලමු දැන් මොකද්ද මෙතන ඇත්තම වෙන්නේ කියලා. So මට තුනම answers ආවනේ. So we'll discuss. It's good that all of you whoever gave the answers you all tried, right? දැන් බලන්න limiting frictional force වෙනකන් හරි. Limiting frictional force මම 4 newtons දුන්නා. friction එකත් 4 newtons, all good, right? ඊට පස්සේ situation එක බලන්න. After limiting frictional force, the friction is the same. Friction එක වෙනස් වෙන්නේ නැහැ. But the force I apply is increasing. මම apply කරන force එක එක වැඩි වෙනවා. මම apply කරන force එක වැඩි වුණාට frictional force එක වැඩි වෙන්නේ නැහැ. It's constant. So here, this is the force I apply. මේකෙන් එන්න වැඩි වෙනවා. But frictional force will stay the same. එහෙනම් shape එක එන්න ඕනේ third එක. It should be the third one. Why is it the third one? බලන්න මෙහෙම කෙලින් ඉරක් තියෙද්දි මේ මං apply කරන force එකෙන් එන්න වැඩි වෙනවා. The force that I apply increases, right? Like this. But all the time the friction is the same. Is this clear to all of you?
Yes, teacher.
Okay. Onara, Tenuli? Tenuli, is it clear? Okay, Onara. Okay. So, මෙහෙම තමයි. Okay. So, this is the shape of the graph, right? Now, දැන් අපිට graph එකේ shape එකත් හොඳට තේරෙනවා. One more thing here ළමයි. දැන් මෙහෙම තමයි graph එකේ shape එක එන්න ඕනේ. But ඇත්තටම in real life මෙන්න මෙහෙම දෙයක් වෙනවා. Right? Something like this happens. That is මේ limiting frictional force එකට ගියාට පස්සේ චුට්ටක් friction එක අඩු වෙනවා. චුට්ටක් friction එක අඩු වෙලා A level එකේ තමයි constant තියෙන්නේ. So according to what we learned here, limiting frictional force එක 4 newtons නේ. එතනින් එහාට දිගටම අනිත් surface එක apply කරන්නේ 4 newton, 4 newton, 4 newtons, right? But in reality, limiting frictional force එකට ගියාට පස්සේ එතනින් පස්සේ චුට්ටක් චුට්ටක් friction එක අඩු වෙලා A level එකේ තියෙනවා. So let's say about 3.8 newtons චුට්ටක් අඩු වෙලා ඊට පස්සේ දිගටම 3.8 newton තමයි. The same, the dynamic friction is the same frictional force. The only thing is that limiting frictional force එක වල චුට්ටක් අඩු වෙනවා. Right? So ඒක නම් මෙන්න චූටි dip එකක් තියෙනවා මෙතන. Okay, otherwise the rest of it is constant. Okay. So now if we label the parts of this graph, මේ කොටස අයිති වෙන්නේ static friction ද limiting frictional force ද dynamic friction ද?
Static frictional force.
Static and limiting friction.
Static. This part static. මෙන්න මේ tip එක විතරයි limiting.
Yeah.
Yes. So this section is the static friction. Static friction. This point is the limiting frictional force. මේ graph එක ළමයි past papers වල අහලා තියෙනවා, දෙතුන් පාරක්ම අහලා තියෙනවා, provincial papers වල අහලා තියෙනවා, term test school papers වල අහලා තියෙනවා. So make sure you go through the graph and you understand the graph. Even now if you don't understand it you can ask me, right? Then මේ ටිකේ තියෙන්නේ dynamic friction. So අපි මේ static friction, limiting frictional force, dynamic friction කියලා කියන්නේ friction නා, not the force that we apply. This part is the dynamic friction. Quickly draw this graph, Lamai. Quickly draw this graph. Then there's a small theory part and then friction is done.
Teacher, done.
What about others? Seneth? Lasas? Okay. Chenuli?
Done, teacher.
All right. Now, let's put a small subtopic. Factors affecting limiting frictional force. Factors affecting limiting frictional force. Then Q can write a question. Does limiting friction okay, what does this mean? ලියාගන්න මේ question එක මුලින්ම and then we'll discuss. Okay. So here what we are going to see is now for friction to occur, there has to be two surfaces and two surfaces are in contact with each other and they are moving, right? So we have to see what about the nature of the surfaces in contact. So make contact with surfaces, they get nature, they go smooth, rough, and we have to see if limiting frictional force is the point where the motion is about to start. So we have to see whether this limiting frictional force depends on the nature of the surfaces in contact. So there are several ways how we can do this. So okay, all right. So what I'm going to do is I'm going to take a few sandpapers, right? My sandpapers keep and now I hope you have seen sandpapers. Valley kadadasi kiyenawa එක roughness තියෙන valley kadadasi තියෙනවා, right? So what I'm going to do is I'm going to take some object, right? මොකරි wooden block එකක් හරි මොකරි ගන්නවා. Don't write or draw anything. Then I also have a table surface or something, right? So මම කරන්නේ එක valley කඩදාසි එක sandpapers of different roughness හැම එකක්ම මේ මගේ wood block එකේ යට surface එකට අලවලා නැත්නම් යට surface එකට fix කරලා මේ table surface එක උඩ ඇදගෙන ගිහිල්ලා බලනවා limiting frictional force එක, right? So let's see how to do this properly. So I have a block of wood, right? I have a block of wood like this. 2D andinna, right? And then I have a few sandpapers, right? So I have a few sandpapers. Sandpaper 1, sandpaper 2 and sandpaper 3. Okay, so sandpaper 1 has the highest roughness, then medium roughness and lowest roughness. Again, rough gati, right? Sandpaper as well. Okay. So we'll see in the first case, I'm going to take my object. So this is the table surface, right? Median table surface. මම මගේ object එකට connect කරනවා sandpaper 1. Right? So I'm going to connect sandpaper 1 to the lower surface of my object. මගේ object එකේ යටට තමයි මම එක connect කරන්නේ. Because යට surface එකනේ අනිත් table surface එකත් එක්ක contact වෙන්නේ. So I'm going to connect my sandpaper 1 to the object, to this surface of the object. And what I'm going to do is I will be fixing a Newton balance. Right? Newton balance කියන්නේ මෙන්න මේ වගේ balance එකකට. I hope you have seen this balance. ඔන්න ඔහොම එකකට තමයි Newton's balance කියලා කියන්නේ. So මට පුළුවන් මෙන්න මෙතනින් යව අදින්න. Right? So what I'm going to do is now I have attached sandpaper 1 to my object and then I have kept it on the table and I have also fixed the Newton balance to the object. දැන් මම කරන්නේ චුට්ට මේ නිව්ටන් බැලන්ස් එකේ මෙහෙම අදිනවා. අදිනකොට එන්න ෆෝස් එක වැඩි වෙනවා. ඔයා දාන ෆෝස් එක ඔයාට මෙතන රීඩ් කරන්න පුළුවන්. Whatever the force you are applying, you can read it from there. So you can slowly 1, 2, 3, 4 kk. You can slowly increase the force. ඔයා ෆෝස් එක පොඩ්ඩ increase කරද්දී at some point what තේරෙනවා object එක ඔන්න move වෙන්න පටන් ගන්නවා වගේ, right? Almost moving වගේ තේරෙනවානේ. අන්න එතනදී you stop and you get the reading on the Newton's balance, right? So the point where the object, then මෙතන අපි Newton's balance එකේ read කරන්නේ අපි දාන force එක, not the friction. No, මම Newton balance එක මෙහෙම ඇදගෙන Newton balance එකේ reading එක ගන්නෙ. So what I'm reading is not the friction, I'm reading the force that I'm applying, right? හැබැයි when the object is about to move, මතකයිද මෙතන? This is the point where the object is about to start the motion. When the object is about to move, මම දාන force එක limiting frictional force එකට equal. එහෙනම් මෙතන මම දාන force එක read කරාට කමක් නැහැ. මොකද මම දාන force එක limiting frictional force එකට equal. So if I'm reading a force here, I know that is also the limiting frictional force. Did you understand that, lamai? Amma, did you understand that? Seneth? Ashwita?
Yes, teacher.
Okay. Hurry. So, notana api limiting frictional force balana, right? So, this is sandpaper 1, right? Here I have attached sandpaper 1. Sandpaper 1. So, I'm going to repeat the same for sandpaper 2, right? මම එකම දේ කරනවා sandpaper 2 එකට, right? So this is my sandpaper 2 and I'm going to do the same, right? Then the same thing I'm going to do for sandpaper 3. තුනේම මම limiting frictional force ගන්න හදන්නේ, right? කොහොමද මම limiting frictional force ගන්නෙ? මම පොඩ force එක වැඩි කරලා when the object is about to move, I get the reading on the Newton's balance because I know that is equal to the limiting frictional force, right? So this is sandpaper 1, this is sandpaper 2, and this is sandpaper 3. Okay. Now sandpaper 1 has the highest roughness, sandpaper 2 has the medium roughness, and sandpaper 3 has the lowest roughness. එතකොට ළමයි ඔයා මෙතන හැම එකෙම readings ගන්නවානේ. So you, when the object is about to move, you take the reading on the Newton's balance. That is the force that you apply. But when the object is about to move, that force is equal to the limiting frictional force. ඒ කියන්නේ ඔයා ගන්න reading එක limiting frictional force එකම තමයි. ඔයාට පේනවා මෙතනදී limiting frictional force is higher and here limiting frictional force is lower, right? So sandpaper 1 is more rough, right? surface එකේ roughness එක වැඩි නම් limiting frictional force එක වැඩි, surface එකේ roughness එක අඩුයි නම් limiting frictional force එක අඩුයි. එහෙනම් අපිට කියන්න පුළුවන් therefore limiting frictional force depends on the nature of the surfaces in contact. Up to that point, do you all have any questions? Chenuli?
No, teacher.
Okay, Dinuki?
No, teacher.
Lasas? Onara?
No, teacher.
Ashwita? Amma?
No doubt.
Amma? Senet? Tenuli? Quickly tell me, because if you have any questions, we have to clarify it right here. No. What about Senet? Oh, why is Amma not responding? Okay. Hi, Lamai. You wrote the question, no? So don't start writing yet. Give me 1 second. Let me just add a few things. Okay, start writing. ඉක්මනට ලියන්න. Your speed is very important, huh? ඔගන්ටම තේරෙයි. Quickly write this, huh? Let me know when you're done. Done?
No, teacher.
Okay, I'll give you a few more minutes.
Done, teacher.
Okay, what about others?
Done, teacher.
Onara? Dinu Kidanna? Ama?
Done, teacher.
Okay. All right. So that is that, and then write another question. Write another question. Does the limiting frictional force depend on the normal reaction force? Okay. So here we have to know what is this normal reaction force. So sometimes we call this brackets atore hari. Sometimes we call it perpendicular reaction force, right? First of all, let me teach you a bit about the perpendicular reaction force. Let's say there's an object on a surface, right? When an object is on some surface, that means there are two surfaces ne. May surface ekai, object ke surface ekai, they are in contact with each other. Two surfaces in contact with each other. So friction is there. Let's completely forget about friction. When two surfaces are in contact with each other, these surfaces exert each other a perpendicular force, right? Now මේ දෙන්න මෙහෙම contact වෙලා ඉන්නකොට table එකෙන් මේ object එකට දෙනවා perpendicular force එකක්. මෙන්න මෙහෙම. Object එකනොත් table එකට දෙනවා. හැබැයි අපි table එක ගැන නෙවෙයිනේ කතා කරන්නේ. So we are not going to consider that. Table එකෙන් object එකට දෙනවා perpendicular force එකක්, object එකෙන් table එකට දෙනවා perpendicular force එකක්, right? But we are only going to talk about the perpendicular force that the table gives to the object, right? මේකට තමයි අපි කියන්නේ perpendicular reaction force, or we call it the normal reaction force. What is this? When two surfaces are in contact with each other, the two surfaces give each other a perpendicular force. That is the normal reaction force. අපි usually මේ R කියන letter එක තමයි use කරන්නේ to show perpendicular reaction force or normal reaction force. So R is the perpendicular reaction force. Let's say object එකක් කොහොම තියනවා කියලා. So an object is on a table surface or something. So perpendicular reaction force is there. In addition to the perpendicular reaction force, අපි දන්නවා ඕනිම object එකකට තියෙනවා ළමයි. There is a force called W. What is this W? What is W, ළමයි?
Wait.
Weight. So now there's an upward force to the object, there's a downward force to the object, but this object is not moving upwards or downwards. එයා උඩට යන්නෙත් නැහැ පල්ලෙහාට යන්නෙත් නැහැ. ඒ කියන්නේ දෙපැත්ත balance වෙලා. හරියට නිකන් let's say in අවුරුදු festivals there's the කම්බාදින තරගය, right? දෙපැත්තම එකම විදිහට දෙපැත්තට ඇද්දොත් කම්බේ මෙහෙට move වෙන්නෙත් නැහැ මෙහෙට move වෙන්නෙත් නැහැ. Just like that, this object is not moving. That means උඩට තියෙන force එකයි යටට තියෙන force එකයි equal ඇති, right? Equal හින්දානේ balance වෙලා ඉන්නේ. So here perpendicular reaction force equals weight. Okay, perpendicular reaction force equals weight. Now let's talk about this particular instance. Now we have a table surface, right? And we have three identical wooden blocks. On එකක් තියෙනවා. This is just one. And then මේ වගේ එකම වගේ දෙන්නෙක් අරගෙන මම මෙහෙම කුඩේ කුඩ තියනවා. The third situation, එකම වගේ තුන් දෙනෙක් අරගෙන මම කුඩේ කුඩ තියනවා. Right? These are all identical wooden blocks, right? So what I'm going to do is තුන් දෙනාටම මම connect කරලා තියෙන්නේ Newton balance එකක්. I have connected a Newton balance to all the three systems. And just like the previous one, I'm going to apply a force and I'm going to increase the force very slowly. තුන් දෙනාගේ force එක මම තුන් දෙනාටම spring balances Newton balance එක දාලා තියෙන්නේ. So I'm going to slowly pull the Newton balance. I'm going to apply a force and I'm going to slowly increase the force. පොඩ්ඩ force එක increase කරද්දී at a certain point you feel that the object or this entire system is about to move. When the object is about to move, ඔටක් ගාලා Newton balance එකේ reading එක ගන්නවා. Because that reading is equal to the limiting frictional force. මේ තුනේ ළමයි, here's the thing, right? Let's say the ඔක්කොම objects identical නේ. So if you take these three systems, මෙයාව ගත්තත් හරි first, second and third, කාගේද weight එක වැඩිම? First or second or third? Third. Why? Because there are three wooden blocks. In the first one, there is only one wooden block. In the second one, there are only two. But in the third one, there are three. So, weight එක වැඩිම third එකේ. දැන් මම මෙතනදී කියවනේ perpendicular reaction force එක equals to weight කියලා. එහෙනම් මෙයාගේ weight එක වැඩි කියන්නේ මෙයාගේ perpendicular reaction force එකත් වැඩි. Right? So, perpendicular or normal reaction force is highest, right? Then what about this? මෙයාගේ normal reaction force is lowest. ඇයි මෙයාගේ weight එක අඩුයිනේ. So weight එක අඩුයි කියන්නේ උඩ තියෙන normal reaction force එකත් අඩුයි. එතකොට ළමයි අපි Newton balance එකේ reading එක බලද්දි මට පේනවා මෙයාගේ limiting frictional force is lower and මෙයාගේ limiting frictional force is highest, right? මෙයාගේ limiting frictional force එක අඩුයි මෙයාගේ වැඩි. ඒ කියන්නේ perpendicular reaction force එක අඩු වුණාම limiting frictional force එකත් අඩු වෙනවා. perpendicular reaction force එක වැඩි වුණාම limiting frictional force එක වැඩි වෙනවා. From that we can say therefore limiting frictional force depends on the normal or perpendicular reaction force. Okay. චුට්ටක් අපි මේක ලියන්න කලින් I will write a few sentences. So I hope you wrote the question. Does the limiting frictional force depend on the normal or perpendicular reaction force between the two surfaces? So here start writing. Make a clear passe. Let's stop. And then you draw this. තමයි ඔයගොල්ලන් පැත්තෙන් මේ diagram එකත් ඇඳ ගන්න. එතකොට ඔයගන්ට තේරෙනවා කොහොමද මෙයාගේ perpendicular reaction force එක අඩු උනේ කොහොමද වගේ වැඩි උනේ කියලා තේරෙනවා. It's because of the weight. පැත්තෙන් චූටියට ඇඳ ගන්න එක pencilෙන් වගේ. Quickly write this one. While you write this, tell me, did you all understand this? Chenuli, Ashwita, Dinuki?
Yes, teacher.
Yes, teacher.
Yes, teacher.
Seneth, Lasas, Tenuli?
Teacher.
Seneth, Tenuli, Ama?
Yes, teacher.
What about Seneth and Tenuli? Okay. Quickly write, huh? Let me know when you're done. And also, if you have any questions, please let me know.
Teacher done.
Okay, what about others? Chenuli?
Done, teacher.
Okay, Dinuki, Seneth? Tenuli, Amma, still writing or done?
Done, teacher.
Dinuki, Seneth? Okay. So, we have a little bit more. I was planning on finishing friction actually, but explain karna chuttak vela ava gaya and it's okay. So there's only one more part in factors affecting friction, limited frictional force, and then a little bit of theory. Period 20 minutes spelling again next week අපේ ඉවර කරාට පස්සේ we are moving to biology. So before next week I will be sending you the biology note for this lesson, right, which is the structure and function of the plant and animal cell. Worksheets ටික as I told you may second වලින් පස්සේ මම ගන්නට worksheets ටික ඔක්කොම එවන්නම්. So I have to send you the biology worksheet and also Newton laws and friction දෙකටම තියෙන එක worksheet එක, right? Yes, so that's the plan for the moment. So before we end the class, do you all have any questions or is everything clear? All good?
Yeah, teacher.
Okay.
Yes, teacher.
Okay, so we'll end the class. As usual, our next class will be on 3rd of May, which is a new month. So those of you who haven't paid fees, please pay and send me the receipt, right? So මට සමහර payments වගේ කැවිලා තිබ්බ without any receipt. So please do send me the receipt. And yeah, that's all I have to say. Yes, have a great week, Lamai. Good night.
Thank you, teacher. Good night, Miss.
Same to you, teacher. Thank you, teacher. God bless.
Good night.